All right. Good afternoon. Welcome to Rapid Research number 4 on accessibility. One announcement is we will hold questions until after the presentation, and then I will be around with a microphone so that people online can hear. Okay, so with that, I would like to introduce Ziran Wang from Purdue.
Thank you, Debbie, for the introduction. My name is Ziran Wang. I'm an assistant professor at Purdue, and I want to talk about our research, which ties a little bit to accessibility and also, I should have changed this one, and also to the safety issue. So increasing accessibility of autonomous vehicles with human autonomy teaming with foundation models. I want to start with these two videos as I shared to several of my friends over the last day about my experience on Waymo vehicles. I bet some of you or many of you have tried this kind of vehicles. This was my very first ride in San Francisco 2 years ago, actually. I was at the UCSF, University of California, San Francisco campus, and you saw the vehicle was actually pretty smart and pulled over just for me because I was a little bit away from the initial pickup destination. That was me and my big face right there just to show that there is no driver on the vehicle. I was very, very happy and impressed about how safe, how smooth, and how accessible technology like this is. It can provide, right? You see that big flag over there. It's a Castro Street of San Francisco, the big part of San Francisco. It's very busy, but the vehicle was very smooth. It can handle everything very smoothly and safely. I was impressed, and I was thinking, whether there are still any research for us to do in university. I will probably lose my job. I as a researcher working on this field, what else can we do in university, right? Not until my second trip on the Waymo vehicle. This was my second trip. You see, my wife was filming. I was filming on the second row. Our vehicle was the first one waiting in the intersection for, change to allow the signal change from red to green, and the signal changed to green, but we were not able to move forward because those two vehicles collided with each other in front of us, right? So obviously the rear vehicle was doing an unprotected left turn, and the green vehicle was doing straight movement, and then they collided with each other. Our vehicle, our Waymo vehicle though, in that place, didn't know what to do. If you look closely on the screen, it said waiting for intersection to clear, but that's all this Waymo vehicle can do. Again, back in 2024, probably they have more advanced algorithm, but at the time, there were no option for us as the passenger or the users of this autonomous vehicle to do anything, to either change any setting, to interact with vehicle. What I ended up doing is I pressed that help button on the screen. I dialed in for help, and then there was a remote operator asking me, what's going on? Can you describe the scene? I was describing that for a minute, and she was like, you know what? I cannot help you out. I'll reconnect you to a technical person, technical support. And I was waiting to get connected to the other person. I was describing the things one more time. Luckily, those two vehicles move away from the center of the intersection, so we were able to proceed. But at that time, I was thinking whether there will be any more accessible feature for us as the users of a autonomous vehicle, robotaxi, so we can interact with the vehicle and let the vehicle know our decision, our preferred action for the vehicle. So probably I just want to take a detour, right? Turn right here instead of go straight, or probably just pull over so we can get off. No, there's none of those options for us. And that led me to thinking whether there might be any way for us to provide human instruction to those autonomous vehicles and autonomous systems in general, right? So that led us to work on this domain of using foundation models. Everyone is using that right now, but we use that specifically to empower our autonomous driving systems. Empower autonomous vehicles to provide higher accessibility for those vehicles to all the general public. No matter what level that they are, no matter they are 17-year-old versus 70-year-old, but we want to leverage the strengths of LLMs or VLMs or all these foundation models regarding their language interaction. They can do very good understanding. They can do very good reasoning. Zero-shot or few-shot planning. You all know that, where you are using GPT every day. So the way we did it is there are two different approaches. But basically, we have tried all those different kinds of foundation models, starting from GPT 3.5, and now, we use Llama, Gemini, Cloud, and whatever. We do two things. One is we run those foundation models as an add-on feature to the existing autonomous vehicle stack, which means we don't mess around with any of the existing module on the vehicle, so the vehicle still have perception, planning, control. But what we did is we used those foundation models to tune the parameters of those rule-based either motion planner or motion controller and so on and so forth. So that's our approach one, and I will show two examples for that. Approach two is what my students are more excited about, right? End-to-end approach. So we just replaced the perception module and planning module, potentially control module, but so far just perception and planning module, with a big foundation model, like what Tesla has been doing for their deep neural network, right? So the input will be camera images and textual, verbal commands, and then output will directly be planned trajectories, so it will be consumed by the control module. So this is our first approach, where we use the so-called human autonomy teaming to empower this, specifically working on the planning module. If you look at this figure, if you ignore the left part and the upper part, again, the lower part of this green phase is your old-fashioned autonomous vehicle, where you have sensors, perception, planner, controller, and actuators. So what we did is we add on this additional feature where we allow human passengers for autonomous robotaxi, or human drivers for level 1, level 2 vehicles, to interact with the existing AV stack. So we also have humans can provide verbal command, and then the speech recognition system will convert that verbal command into text, and then we can also provide feedback. So the feedback will be sent to the memory module and then also sent to that LLM right there that can do all those reasoning based on the input from the human, as well as the weather information, traffic information, what's the speed limit, and so on and so forth, then output the code. So the code will be directly executed by our motion planner, and then we can do things like in a more personalized and interactive way. So I'll show you what I'm talking about in this demo. It was
command. The game is about to begin. I don't want to be late.
So this passenger says something like, so it's, again, the scenario was like a big parking lot scenario where this passenger was taking this robotaxi to a big football game, and he said something very high level, the game is about to begin, I don't want to be late. So you don't have to say something very explicit, let's park near to that parking space behind a tree, 5 meters away from the entry gate. No. Just say something very high level, and then LLM will do that thing for you. So it will go to find the place, and then park to the spot that's closest to the football stadium. And then you can still provide feedback.
Evaluate. Even though I'm
you
in a
switch
hurry,
on the feedback by saying something like evaluate, then he figured out let's park near the exit, so we can
command.
Exit
the game
as
will
soon as
begin
possible.
in 5 minutes.
So next trip, you say something still very high level. The game is about to begin in 5 minutes, but this time because that feedback, LLM will be raising that and then make the decision. Let's park near the exit.
I'm satisfied
and
with
then you can
this
still
trip.
provide your feedback, right? I'm satisfied with that trip. So that was the human autonomy teaming process for the parking lot scenario. We have another scenario. It's called unprotected left turn, one of the most risky scenario of driving, and the passenger was showing a kind of urgency of driving. I'm on my way to the emergency.
I'm on my way to the emergency.
And then what the vehicle ended up doing is turn left at that intersection before the other vehicle passes, right? It's kind of risky,
Evaluate.
and he didn't like it. He said, even though
though
sometimes in a hurry,
I'm
next
in a
time you should
hurry,
still wait for the opposite vehicle to pass.
Wait for the opposite vehicle
And then
to pass.
LM was able to take
Command.
that feedback.
I will be late for
And
meetings.
then next time you say something still very high level, I will be late for a meeting. You still have that kind of urgency, but this
Command.
time the vehicle will
Let's
decelerate,
continue turning when it's
wait
clear.
until the other vehicle passes. You can still provide your feedback. Command, let's continue turning when it's clear. Both command and evaluate, those are more like keywords like hey Siri or hey Alexa. But this time the vehicle was able to wait, be safe,
Evaluate.
and then turn left
I'm
after
satisfied
that.
with this
So this
trip.
time,
Command.
again, it's done.
The front
third trip
vehicle looks
is
weird.
a car falling trip where you have a erratic driver that's driving very crazy in front of you, like we always see on our roads every day. This time, our passenger says something very abstract. The front vehicle looks weird. But based on the sensors of our vehicle, detects that vehicle and then decides by LM, let's just pull to the right, stay away from the vehicle to be safe, right?
Evaluate.
He was not happy. He said something
Next
like,
time, please directly
let's just
overtake the front vehicle.
directly overtake that
Command.
vehicle. Second
The
trip,
front vehicle looks very
front
crazy.
vehicle looks very crazy. High level command. LM was able to do the reasoning, make a very smooth and safe, lane change to the left, overtake the vehicle. We assume those 3 lanes are in the same direction, and then he was happy about it.
Evaluate. I'm satisfied with this trip.
So this short demo video showcases how foundation models can really help our autonomous system out in regards of understanding the needs of humans, and then we can potentially increase the accessibility of such a complex system, right? Autonomous driving can be a very complex system. Like FSD, wow, I experienced the whole day yesterday riding on FSD, Tesla FSD. There are so many different features I can tune, which might be not that accessible to, say, my grandma or my mom. But if you have this high-level interaction with such a system, we will make things work that more understandable for all levels of passengers. And then we work on this one as a subsequent study for the previous one, because first, the previous one, we leveraged the cloud API from OpenAI back then. So we used GPT-4 on cloud. It was kind of laggy because we have to send everything to the cloud. We have to get the feedback from the cloud. The end-to-end latency, speech recognition, computing, communication can be up to 5 seconds, which is not ideal. So my students thought, why don't we deploy everything on board, on the vehicle? So why don't we train a smaller model, not necessarily to have a large model always, but a smaller model, which in this case, we fine-tune the Q1 model with 10K image text pairs training data set. When we also, because this project is one of the CCAT project, where we look at how autonomous vehicle or kinetic autonomous vehicle will behave in the winter weather here in Midwest. So we actually went out to our field. We spent a lot of time collecting a lot of those data in all kinds of weather in Indiana, which is very similar here in Michigan. We have sunny weather for sure, but rainy, foggy, snowy weather, and night weather. And so all those data, they were used to fine-tune this big onboard VLM. What we did is we took text input, we took camera image, and then we used VLM to fine-tune the parameters of those 2 controllers. For those of you who know control theory, we use PID control for speed control, so longitudinal control, and we use MPC, model predictive control, for lateral or lane centering. And then all we did is we pretty much connect the input to the output, and output are the values of KP, Ki, and KD, and all those 3 values of MPC algorithm. And I'll show you the demo video, which might make things easier to understand. So I'll show this turning scenario. Again, unprotected left turn. The first trip, so it was like a baseline autonomous driving feature. Was taking this vehicle to a left turn, and then you see how speed changes both longitudinally and laterally. And then the second trip, we have LM or VLM helping out. And the passenger was providing some input.
Command. I feel a little bit motion sick.
So he felt uncomfortable. And then let's see how vehicle will respond this time. Simple idea. Let's just make the speed and acceleration more mild, right? Let's make the acceleration smaller so he feel better. He feel more comfortable. So you see the curves are actually
Evaluate.
more mild. They change
Drive
in
in a more gentle way.
But he was not happy. He said, something more gentle. Let's just drive more gentle, be even slower. So the third trip, after we incorporate that feedback, you see how it will
Command.
respond to that.
I feel uncomfortable.
Again, seeing something very high level, I feel uncomfortable, but based on VLM, based on all those inputs, you see the new curves, the red curves are even, the slopes are even smaller than the previous 2. So you further tune the system to make it more personalized and make it more
Evaluate.
accessible for all kinds of drivers, right? Yes. And the last one that we have done very recently is we want to make things even faster. We want to deploy things on board and make the delay into millisecond level. The second one, which was on board but still 2-second delay, this one we use the diffusion backbone. For those of you who know machine learning theory, the way that diffusion models work is a little bit different than traditional large language model, which is like autoregressive models. So they can do things in parallel, which can actually facilitate things, accelerate the decision process for such a big foundation model. So we use diffusion language backbone and then generate the outcome. So you see the results are even faster than the previous one, the last demo video that I will play here, where we can allow the vehicle to make real-time decision, like
Come on, park close to stadium.
This time, 200 milliseconds, right? Within 2 seconds, the first decision will be made compared to what we had early on, 2 seconds. And then what's beautiful about this is this passenger can provide
Come
real-time
on, park
feedback.
here.
Say, come on, let's park here. I changed my mind. And then take another 0.2 seconds, and then the vehicle was able to do that reasoning and make the decision. So this is what we have been doing recently, still under review work, but we are leveraging the foundation model, the diffusion model backbone to empower our foundation model and make it more efficient. All right, so I think this is a conclusion slide. We are building this human autonomy teaming concept to increase, of course, safety, efficiency, and in this case also accessibility for autonomous systems to better serve for humans by leveraging foundation models, advantages of all of that. We have a few examples, and feel free to check out our latest publication. I think we listed it right here. We just published on the Proceedings of the IEEE, very prestigious journal. I want to also thank my students, and that's not my student. He's more senior than me. It's Jeff Dean from Google, but he was paying a visit to Purdue 2 years ago, and ironically, we were running GPT while he was riding our car, and he was like, "Why don't you run Gemini?" We said Gemini sucks at that time. And now Gemini 3 is very good. So he's the mind behind Gemini. And then that's the person who got hit by playing soccer, not by his algorithm. But he's the lead for all that. He's now working for Bosch AI Center in Silicon Valley. And his name is Ken Kui. So all the work are done by him. And with that, thank you very much.
We have time for 1 or 2 questions. Anyone have a question? We'll do 2. We'll do you 2.
Okay, sure. That's very interesting. How do you ensure security if someone sabotage and try to hit the person?
So you see the sponsors is one of them is Toyota, right? And for everyone's background, I worked for Toyota for 4 years. So I have that OEM safety mind back there. The way that we did it is, as I said, that's why I prefer the first approach, where we use that as an add-on feature. So we always have a parallel system or safety filter that's always checking the outcome for foundation models. And every time the foundation model have any hallucination or anything out of the bound, we kick it out. We fall back to our rule-based algorithm just to be safe. And of course, we have all those safety filter within the foundation model that we already set the boundary for how foundation models can tune our parameters. But again, anything that's hallucination happen, we kick it out, we fall back to our rule-based algorithm, which might not work for the end-to-end approach. So that's why I still prefer the traditional modularized approach in my case.
Hi, Kevin McCoy at Volpe Center. I'm wondering if you've tried to apply this to non-vehicle occupants as well, like for example, traffic control, law enforcement, or emergency situations to be able to direct automated vehicles.
Yeah, we have been discussing this idea with our state DOT, Indiana DOT. Yes, that's definitely at least of my research interest. But again, hallucination can happen, and that might make things chaotic, right? If you want to purely rely on foundation models to do all those high-level management for a fleet of vehicles, that can be chaotic. But if you just use foundation models for high-level decision and prediction and planning, that can be definitely useful. But we are still, I'm saying that we're educating them, but we are working with our state DOT folks. So, talking them into this, new generative AI thing, which can be a tough process.
Thank you. You'll have to see him after. We got to get to the next speaker, but thank you.